Welcome back to The Explainer. Today, we are diving straight into a fascinating journey. We're looking at the unseen geometry that literally makes or breaks dental restorations, the path of insertion. It's kind of seen as this basic foundational concept, but once we really zoom in on how this single angle dictates absolutely everything from mechanical survival to gingival health, it completely reframes how we evaluate crown and bridge work. So let's start with a bit of a mystery, right? Have you ever wondered why seemingly perfect dental work, we're talking crowns milled with micron-level precision by incredibly advanced machines, why do they sometimes just fail completely once they're actually in the mouth? They loosen up, they chip, or they leave these tiny gaps that lead to massive infections. Now, you might be quick to blame the material, or maybe the cement, but honestly, the truth usually lies way back before the crown was even manufactured. It's a domino effect caused by poor foundational planning. And that leads us straight to the star of today's explainer.
All right, let's get into Section 1. What exactly is this path of insertion?
Basically, the path of insertion, or POI for short, is the specific trajectory or direction that a crown or bridge is seated onto prepared teeth, implants, or abutments. Think of it like trying to jam a rigid lid onto a perfectly fitted box. If you angle it even a tiny bit wrong, it binds. It gets completely stuck. In dentistry, especially when we're dealing with a bridge that spans across multiple teeth or implants, all of those abutments and teeth must share a single, perfectly aligned common path. Actually, scratch that. It's not just a common path. It's an absolutely non-negotiable shared trajectory for easy, accurate seating. Okay, let's really visualize this. Imagine parallel dashed lines extending downward toward the implants in the jawbone. This brilliantly represents a common path of insertion across a multi-unit bridge. Notice how the internal shapes of the crowns have to correspond identically to the angles of the abutments right underneath them. If just one, literally just one of those underlying abutments is tilted off-axis without correction, the rigid bridge structure above it simply won't seat. The physical interference just blocks the restoration from ever reaching its final destination. So this single alignment dictates the success of the entire complex structure. It's wild when you think about it.
Moving right along to Section 2, ensuring proper physical fit.
When we actually get this right, a few incredibly important physical things happen. First off, we get proper seating. A common path allows the restoration to just slide into place fully without physical interference, giving us incredibly accurate adaptation to the tooth or implant. Second, we achieve what's called a passive fit. This is absolutely vital in implant cases. A passive fit means that when the bridge is screwed or cemented down, it isn't torquing or pulling on the implants. That minimizes the stress on the implants, the abutments, the tiny screws holding it all together, and most importantly, the surrounding human bone. And third, it prevents those dangerous marginal gaps from forming at the base. There is just a stark contrast here between getting it right and getting it wrong. On the correct path side of things, we see perfect preparation. The walls are properly aligned to increase the restoration's retention and stability. That significantly reduces the risk of the crown loosening or dislodging while someone is, just chewing their lunch. But look at the alternative. An incorrect insertion path practically guarantees that the crown will not seat all the way down. And boom, that creates an immediate, very dangerous open margin between the crown and the tooth structure. And guys, an open margin is essentially ground zero for clinical failure. Here is the rapid-fire domino effect that takes place when that insertion path is off. Step 1, the restoration binds, and an open margin forms right at the gum line. Step 2, because there's now a physical ledge or gap, plaque and harmful bacteria rapidly accumulate in a tiny space the patient simply cannot clean with a toothbrush. Step 3, recurrent decay rots the tooth structure from directly underneath the brand new crown, and severe periodontal problems begin to destroy the surrounding gums and bone. All of this destruction simply because the initial angle of insertion was slightly off. Which brings us to Section 3, improving durability and aesthetics. Let's rapid fire through the mechanical nightmare scenarios that proper alignment helps us dodge entirely. When the insertion path is spot on, overall structural integrity skyrockets. You decrease the risk of screw loosening, which, let's face it, is a massive headache for both patient and doctor. You prevent framework distortion, where the metal or zirconia skeleton actually warps under tension. You heavily reduce ceramic chipping, abutment fractures, and excessive occlusal stress from a bite that's suddenly thrown way out of balance by an unseated crown. These are incredibly high stakes. Proper alignment isn't just a suggestion. For sure, it is the ultimate defense mechanism against catastrophic mechanical failure. But hey, let's not forget the art alongside the engineering. A restoration must survive, yes, but it also has to look beautiful. A well-planned insertion path is the secret sauce behind a truly natural-looking smile. Because the crown can seat fully and precisely exactly where it belongs, the ceramist can create ideal contours. They can completely perfect the emergence profile, which is how the artificial tooth appears to naturally grow right out of the gum tissue, just like a real tooth. If the path is wrong, and the crown ends up bulky or unseated, the illusion is completely broken.
All right, shifting gears a bit for Section 4, enhancing digital CAD/CAM workflows.
We are obviously living in an era of incredible digital CAD/CAM technology. Dentists scan mouths with highly accurate lasers, and technicians design teeth using super advanced software like Exocad and 3Shape. But here is the absolute crucial point. These digital workflows rely completely on a clear, physically possible insertion path. The software can design the most gorgeous tooth imaginable, but if the underlying path of insertion wasn't planned correctly by the clinician in the first place, the software is just going to highlight the undercuts and collisions. Digital precision is amazing, right? But it must perfectly translate into physical reality. The software is entirely dependent on the foundational planning of this one single physical path.
Let's wrap up the technical breakdown in Section 5, clinical and laboratory perspectives.
And this brilliantly illustrates the harmony that happens when the insertion path is perfected. It acts as a literal bridge, pun totally intended, between the dental clinic and the laboratory. For the dentists, it means easier impressions or digital scanning procedures, far better seating of the final restoration without grinding and adjusting for hours while the patient waits, and a vastly improved long-term prognosis. On the flip side, for the dental technicians in the lab, it means much easier CAD design, highly accurate milling and manufacturing, and a massive reduction in costly remakes and frustrating adjustments. Basically, everyone wins when the foundation is sound. Let's distill all of this down to one incredibly powerful final thought from our source material. A crown or bridge can only perform as well as its path of insertion allows. It literally does not matter if you are using gold, porcelain, or the strongest zirconia on the planet. Whether the restoration is supported by natural teeth or titanium implants, a properly planned path of insertion is the absolute, undeniable foundation of excellent fit, function, aesthetics, and long-term success. Like they say, you simply cannot build a great house on a crooked foundation. So, I leave you with this final thought. How will focusing on the foundation of insertion planning transform your approach to long-term restorative success? Next time you see a beautifully finished dental crown, I really hope you take a second to appreciate the unseen geometry, the precise planning, and that crucial common path that allowed it to seat perfectly into place. Understanding these hidden mechanics truly elevates how we view the intersection of biology, physics, and design. Thank you so much for joining me on The Explainer today, and keep looking for those fascinating structures hiding right beneath the surface.